Hello! Thank you for joining us. Today we'll be talking about a hot topic, I would say, that compares two machine learning tools that have been famous these days, Kubeflow and MLFlow. Which one is better? Are there any similarities between these two tools? And how to choose the right one are some of the questions that I hope we will be answering. But I'm not the only one that should be talking today. So together with me, I have two machine learning experts. Maciej, we have a history of having webinars together, I would say.
Yes, hello everyone. So my name is Maciej Mazur. I'm the principal AI engineer in Canonical. And basically what I'm doing is helping people out on building up their MLOps infrastructures using open source tools and also helping out using open source models and in general benefiting from the community in the approach to building AI-driven applications.
I think you said a big word today, Maciej, and that's community. And since I thought we might become boring if it's just the two of us, together we also have Kimonas, who's an active member of the open source community.
Uh, Very happy to be here, actually. So yeah, I've been a contributor actually to Kubeflow for more than 4 years, and now also a tech lead in two of the working groups for notebooks and integrations and manifests. Really excited to be part of this talk, actually, to be honest, because it's something we talk a lot about in Upstream as well. So that's really exciting. And also, I've joined Canonical as well, as the engineering management manager for Charm Kubeflow, which also seems very interesting to get another perspective of how the project is also used. And we're really doing exciting things. So looking forward.
So, whereas Kimonas, I'm quite sure he's going to pitch Kubeflow as being the best option in town. I'm quite curious which part Maciej is going to take. But before we get into that, I'll go a bit through the agenda. We'll touch upon MLOps or machine learning operations and how open source plays a role in this landscape. And then we'll move directly to the main topic, Kubeflow. What is it? MLFlow, what is it? And last but not least, how do we compare these tools? Uh, Maciej has very strong opinions about that. He says that we should not properly compare them, but rather focus on the use cases. But I'm not telling more now. So let's dive into the AML challenges because these days we see a lot of announcement, blog posts, use cases with generative AI. We see ChatGPT being used for everything and a GPT for almost every other use case that you can imagine. However, when it comes to artificial intelligence, there are still challenges on the market that still need to be addressed. When it comes to skills, there is a huge gap. And I think in Canonical, we see it more than ever. We do talk to companies, we talk to people who are about to get started on it, but they don't know how. A couple of weeks ago, actually months, we ran a social media poll on that, and that was the biggest challenge, how to get started. And it relates to this, but regardless of that fact, there is also a technology gap. Qflow and MLflow end up being compared not just because they have flow in their name, but also because it's a fast changing landscape. There are new tools popping up every other day, and then as a data scientist or as a machine learning engineer, it's impossible not to question it. How do I choose the right one? Which one is better or more suitable for my own use case? So this is another challenge that we do have out there. And then when we think of data, well, one of our colleagues says that data is the heart of AI, and I quite like it. But often we work with highly sensitive data, with a huge volume of data, and this raises some of the big problems that we have. And then if we think of enterprises themselves, they often ask about user management. They often ask on how can a team of 50 people can work using one tool. And is there actually an open source solution that could cover this specific use case? Well, I think that this is how we end up talking about machine learning operations or MLOps as a practice that actually addresses some of these challenges, if not all of them. And Maciej, would you like to go ahead and dive into MLOps? Because I know that's your area of expertise more than mine.
Yeah, sure. So basically, MLOps is coming from the work that has been done by our delightful colleagues from the DevOps departments. And basically, whenever data scientists came into a picture, there was a bigger hype on using AI/ML in enterprise projects. There was a need to have some structured process, because how data scientists or scientists in general were experimenting previously was just running stuff either on their own local machines or bigger high performance compute clusters, a cloud, training a model, and basically providing an outcome. However, this has nothing to do with productionizing things, and the whole idea behind MLOps is being able to take the output from the data scientists and move it around through the whole process so that it actually benefits the end user and is served in various different shapes and forms.
Should I oversimplify it and go back to my definition that is DevOps, but for machine learning?
I wouldn't oversimplify it that much. So basically, if we look at path to production, right, we have the model. What we need to make sure of is that we host it in a correct way, because if we make a nice computer vision model that detects things from the camera stream, we might need to deploy it as a Docker container as part of the bigger infrastructure. We might need to have an API that people can call to get some predictions out of it. We might need to embed it into a mobile application. This is all different. And we don't really want a data scientist who is an expert in computer vision to start building all of these outputs. That waste of their time and also additional skills that they would need to acquire instead of working on the newer generation of the model. We also have a lot of stuff that needs to be scheduled, because some of the training processes of the model can take a week or 3 weeks or even more. And that obviously also requires a lot of resources. You need to manage them, manage access to the GPUs, share GPUs between the teams, scaling up Kubernetes clusters, tons of stuff that needs to happen. So in order to put it to production, there are many steps, but it also needs to be put in a way that is compliant. We have all the security teams, CISO running around and making problems that, okay, you cannot really do it this way, or who is actually providing security fixes for TensorFlow or PyTorch in your environment, and that kind of strange questions that in the beginning no one cares about.
I'll be here the devil's advocate, Maciej, and I'll ask you a question that we also often get. Once you have a model in production, does it all end there, or what's happening?
Well, we have a model in production and it's working. And even if we make a perfect fraud detection model that catches all the frauds that are done on the credit cards right now, that's awesome. But what would happen next is the fraudsters will become smarter. They will have a new way of doing fraudulent transactions, and our model is not detecting them. So in order to have constant performance in ever-changing world and environment, you need to retrain your models with the new data that you got with next day and so on. So that's why it's important not to just run it once and keep it there, but actually adjust to changing environment.
Thank you very much for that. And I think you're right. But since we are all working at Canonical and we have open source in our DNA, so I'll challenge Kimonas right now to tell me a bit more about the open source MLOps landscape. Does open source really play a role when it comes to machine learning operations?
I think it plays a huge role, and I actually think the reason it plays this role comes organically from the complexity of doing MLOps. So Maciej did a very good explanation on why MLOps is difficult, because you have a lot of different teams, you have different practices that you need to apply, like versioning of the things that you create, having some workflows to run to training, do some CI to test that the model is okay. So all of these are complex things. And the reason we do have MLOps for open source is because while these things are complicated, these processes are complicated, each company ended up doing their own kind of thing. So we've had seen so much duplication of efforts where it was almost so evident when some open MLOps projects came to life, when so many companies actually really got invested and said, oh yeah, we also have these pain points. Let us all try to coordinate together and try to fix these issues. So yeah, OSS MLO, it is quite important. And it's actually important because it tries to gather all these people and companies that do it their own way on one place to try and solidify and agree on some best practice and how to do this. And that's why it's good, because of open source.
I will also add one thing here, which is really the heart of open source, that everyone can use it. And I think it's important when it comes to new technologies or almost new trends on the market, because I said it in the past, when I was a student, machine learning was not so popular. And it's with the help of open source and open source tooling that actually I could get started, I could experiment, and then I could get familiar with tools that are open source. So these days I find it quite handy. Last but not least, you didn't mention much Kimonas, but having or being part of a community, it's quite a powerful as well as an inspiring activity itself. When you feel you're too tired of contributing to Kubeflow, you do have some of your community colleagues who keep going, and you say, oh well, there's someone else, I'm not alone, so I can take a few more steps.
Oh yeah.
And I'll ask now something very controversial, since we talked about open source MLOps, and it's worth mentioning that both Kubeflow and MLFlow are open source machine learning tools. But which one is better? That's a question for both of you. Kimonas, you can answer first.
So it's on. The competition is on.
Yes, let's see who wins.
I think that both, in my mind right now, where both projects have some similarities, where they allow you to do some exploration work, they both have some of their strong points. I mean, so it's not that obvious to say, oh, it's one over the other. To me, one of the projects can give you some of more, I think production ready is heavy, but some workflows to achieve some of the tasks for getting from your notebook, doing some automation and preparing your data with some pipelines and serving it. While MLFlow can also allow you to do the experimentation, but has a really nice story around how to also track the lineage and how the artifacts are produced and take them from there. So that's my high-level overview.
Maciej, how do you counterattack it? What are your thoughts on which one is better?
Well, my thoughts are a little bit different, because I don't really think that you can compare them one-to-one and say that one is better versus another, because they serve different purpose, right? So Kubeflow basically allows you to utilize Kubernetes for machine learning in a proper way. If you are using something else, like, I don't know, you are working on SageMaker and you want a model repository, you still can go with MLFlow, right? So you are like, Kubeflow is really part of CNCF and Kubernetes ecosystem, and it's something that allows you to use ML there. MLFlow is a way to track and package and log parameters of the models all across the board in different environments. So yeah, I think that their purpose is a little bit different, and actually the best way, if you are on Kubernetes, is to go with both of them together.
I think I have a lot of questions for both of you, but I'll move forward to Kubeflow itself, because I will assume that in our audience there are a lot of people who are not necessarily familiar with it. So what is actually Kubeflow?
So to touch upon what Maciej also previously said, indeed, that's a quite important actually detail for Kubeflow, which is it's aimed to be on top of Kubernetes, and this is actually its scalability and take it everywhere you want, asterisk, wherever you can run Kubernetes on top. So Kubeflow aims to be a platform to give you some practice and tooling for how to do a lot of the MLOps and model lifecycle workflows that you would need. So it can provide you tooling for spinning up your notebooks and doing some data preprocessing and preparation in there. Also some pipelines. So after you're done playing around with your notebooks and trying your small models, you can then automate the whole process on how to preprocess the data, train the model, log it somewhere. So this is also why we have pipelines. At the same time, it also provides us with tooling for being able to do both AutoML and training on top of Kubernetes. Things of like distributed training on top of Kubernetes with tools and frameworks like TensorFlow, PyTorch, Paddle, which is new. And of course, AutoML also fits a little bit there, which allows you to use the previous mentioned tools like pipelines and the training and the distributed training, so that you can find the best set of parameters while training your model. So these all kind of playing together alongside with serving. Once you have the model, let me serve it. And all of this, again, the important part is it's on top of Kubernetes. And actually, I think it's important to say that the very important question here is, okay, so then what is Kubeflow? Is it just a combination of different tools that tells you, okay, here's how to install these tools on top of Kubernetes? The answer here is no, but at the same time, it's difficult to fully define it. The initial the first simple answer is that Kubeflow tries to take a more of an end-to-end approach on how to manage and run this process on Kubernetes. So it will provide you some abstractions like some user isolation with namespace and different roles. But to me, the heart of actually what Kubeflow is and where Kubeflow should go is what is the glue that can tie all of this together into an actual cohesive story, which for me, it's actually metadata and being able to track lineage so that I know once I see a model, where did this model come from? What pipeline trained it from? What version of the data did it come from? What features were used for that model? So this is actually then the glue that ties all of these in a platform alongside with how to handle users on top of such a complex platform such as Kubernetes. And this is why I also agree with Maciej that Kubeflow and MLFlow should actually be used together rather than comparing them right now.
Don't spoil it, Kimonas, yet. Probably we'll get there as well. But I do have I'm thinking now of the questions that we often get when we talk about Kubeflow. And the first one is, oh, does it have a UI? Or is just a command line tool?
So that's a good question as well. So initially, we didn't have a lot of UIs, but thankfully, the community realized early on that it's actually quite important to enable users because Kubernetes has a ton of complexity. So we cannot expect, as Maciej previously said, like the data scientists to be able to also go into the Kubernetes and handle things themselves. So that's why with Kubeflow, we actually do have a lot of UIs to try, and this is a constant goal we have to always try and abstract away the low-level Kubernetes details. And that's why we try to have at least a graphical interface for most of the things that people would need to do with the platform.
And another question that I think we often get is regarding the user story. Is Kubeflow designed for teams or just for individuals?
This is a very good question that I'll give the diplomatic answer initially, and then I'll add some more details. So initially, we wanted to have teams. This is why we have a concept of users and modularity of permissions for users. Like I want someone to be a viewer, I want someone to be an editor, I want someone to be an admin, and people could share resources so someone could not delete other people's notebooks, for example. But the truth is, first of all, this has two scales. One is how, on the security and implementation level, how much can we do with Kubernetes? And this is where we actually start seeing some of the limitations on the current approach that we have in Kubeflow, which the very short answer is we cannot just always use one namespace and put a lot of different users in, especially when we have teams. And then the other building block, which I'm also excited because I'm seeing some nice progress in Canonical, is in order to have different teams, you actually end up having context about users in two different places. You need to have both the Kubernetes part up to sync with what are your users and what are your groups. But most of the time, the groups and the users are defined in some other LDAP or identity component. So it's also a discussion of how to keep these two in sync and how to, in order to be able to effectively have a multi-user story, which we're actually improving, but it still needs some refinement to get to a fully seamless experience.
And since we talked about Kubeflow, it's worth mentioning that actually the community itself has been doing huge efforts. There are 2 releases every year, if I'm not wrong, with the new one coming up in about 2 to 3 months. But before we move forward, there is a Juju logo here, and my next slide talks about the difference between upstream Kubeflow and churn Kubeflow. But what is churn Kubeflow, Kimonas?
That's an interesting question that I also had 2 months ago, and I'm really excited to actually share the answer that I have, considering that I've being someone that came from actually just developing open source to actually seeing a flavor of Kubeflow that is owned by Canonical. So what churn Kubeflow actually provides is, you can think of it as, it's not just Kubeflow, but you also, all of the operator logic that you need for handling Kubeflow, and by handling, I mean how to install it, how to ensure it's up to date, how to do most used configurations, which would require Kubernetes knowledge. how to do upgrades, which is huge. These are some of the first ones that blew my mind when I came and saw. So all this operator logic, it's actually integrated with Charm Kubeflow. It's charms, it's operators, which is that was the initial wow phase for me. And then it actually got even further when I realized that the whole premise and actually Canonical's goal is to how can abstract software in a way that it's fully pluggable and can work across even different platforms like even Kubernetes and VMs. So it really blew my mind when I realized that it's so easy to actually integrate with components like here's an observability stack. Here's some other ML tooling that we can just define that I want my Kubeflow to also integrate with this tooling, and everything just happens kind of automatically. And for me, yeah, that was oof.
I think you captured it correctly. So Charm Kubeflow is it's Canonical's official distribution of the upstream project, and I always defined it as the foundation of a growing MLOps ecosystem where we integrate with a bunch of tools such as Grafana and Prometheus as part of the observability stack, for example. But we also use it, or we also test it on AI specific hardware. If we can just mention NVIDIA's DG Axis. Last but not least, when it comes to enterprises themselves, we offer support and managed services, which is quite important as well. And I didn't even mention that much about our security story. But the main reason for that is that I'm also trying to be conscious of time. So I'll move to MLFlow with Maciej's, I think, knowledge. Let's see how that goes. What is MLFlow,
sure.
Maciej?
So basically, MLFlow is a nice tool that allows you to integrate it into any MLOps process that you might already have, or use it in building a new one. And that's the most important, I would say, difference here, because if you already have a process on Azure ML or SageMaker and you don't want to move out of there, you can still use MLFlow there and all of its components, like the tracking component that allows you to basically record your training sessions, how they were run. You can have it via different APIs, Python, R, Java, whatever you are using in your application. You have the component with models, which gives you a standardized packaging so that you can reuse those models on different public clouds, on like local environment, on VMs, or wherever you want. And also there is a model registry component, which is the biggest thing there, because that needs to be used also with Kubeflow and all the other tools if you want to have a repository of all your models, and also different stages in their life cycle, what is on test, what is on production, and so on. So it gives you a lot of nice components and structure around it, but does not impose a certain way of working. Kubeflow gives you a very good idea, or if you are on Kubernetes and you don't really have an idea how to set up an MLOps process, you get already a super nice prescribed setup, which you might say is good. It's coming out of Google. They base their Vertex AI platform on it, which is super popular. So this is like really state-of-the-art way of moving your artifacts through the process. However, if you already have a working process and you don't change it, you need to look for tools that are easily integratable. And I think that the integration with all the other tools is biggest benefit of MLFlow. And if we look at the next slide on how it integrates, for example, into Azure process, you can put it in the way that we see here on the picture. That's how Databricks is doing that, also one of the major contributors to MLFlow. And basically, you can have staging of your models. That's also a concept that is missing from a lot of MLOps tools. Even in MLFlow, it's really elaborated so that if you need to grow blue-green deployments or canary deployments, because your model is really the heart of your business. If you are Uber looking for ride sharing, figuring out the time of the ride, and you have a model for that, you cannot really randomly put a new model that you think might be nice into production, right? So you have different environments, you have different ways of moving, like first 100 users, then 1% of your users, then 10, then 50 to a new model and to a new infrastructure. And MLFlow is the tooling that supports that with a standardized packaging. So if you, for example, later on change from PyTorch to TensorFlow or the other way around, or use something different, it's still same packaging model, same code to deploy it, make stuff easier, saves your time. That's the whole plan.
Do you think MLFlow is one of the tools that is very helpful for developers who are just getting started with AML, or it's something that's needed along the way?
Well, that's another benefit, because if you are getting started and you don't really know yet what to use and you want to experiment a lot, you can keep MLFlow as your main model repository and standardized package format and try to play around with Kubeflow, play with SageMaker, Azure ML Vertex, store your models there, maybe play on something completely locally that you developed by yourself. You want to experiment with LLMs, use local AI. All of this can still be stored as parameters of the experiments. What weights did you use for your neural network? What kind of Python libraries, which versions were used in the environment, regardless of where it was. So if you are learning and starting out, MLFlow is super useful to structurize and systematize your knowledge about what you have learned. It's not really a production use case, but for people who are new and learning to be data scientists, it's a really amazing tool to keep structure of what you learn.
I'm almost tempted to ask you if that's how you started your AI journey, Maciej.
Well, unfortunately, I started in a dinosaur age where there was no nice tooling to help you out. So I was starting my data science career like around 12 years ago doing telco networks optimization. We had to code everything by hand. There was no nice tooling, no open source communities around it. So now it's much better and much easier to start.
Well, that's good, and I'll move further with the comparison of Kubeflow and MLFlow, and I'll start with the similarities. What's similar between these two tools? I know they're both open source tools and they're designed for machine learning. In a previous conversation with both of you, I said that they're both ML platforms, and we had a bit of a debate. So I'll say that they're just used for machine learning this time. However, what other similarities would you like to highlight when it comes to these two tools? Maciej, would you like to kickstart it?
Yeah, so basically the main similarities, obviously these are all open source tools to which a lot of people are contributing to and benefit from the community part of it. Super useful because you can also audit what's happening inside. If you want to use it in regulated environment in production, you will get a lot of more assurances about the source code, have an SBOM, like software bill of material, how secure it is, and so on. They also both work very well with notebooks and with model serving tooling. Some of the model serving tools are already in Kubeflow, like you have Seldon and KServe. You can add more serving tools into MLFlow if you use something different, but still, I think that all of those tools are giving you a nice way to track your work and collaborate with other people, and I think that that's the biggest benefit. Kimonas, what's your opinion?
No, you actually covered it perfectly. It's actually those powerful items where at least experimentation for the and integration with model serving. This is one of I think the biggest right now common ground on these two projects. There is also a little bit of artifact tracking, but I think that the degree to which is implemented by both is different. So while there is a notion there, I think that the strongest points are the ones we discussed above, like also scalability and portability, which is huge, as well as customizability. Although this is a lot of times a two-edged sword, because when you give too many options to people, they might tend to a little bit hurt themselves sometimes, but it's still something that allows for powerful enablement.
Now, in this case, let's go to the controversial part. When I suggested Maciej this webinar, he said, hey, it makes no sense to compare them. They're designed for different use cases. And that's the image that he added. So, Maciej, what's the difference between Kubeflow and MLFlow?
Yeah, so as I said, it's like sort of apples to oranges comparison, but it's really important that we are making the webinar here because there are a lot of people starting their journey in that space and having like a lay of the land and an idea of when to use what and how is super important. And when you don't have any experience, it might seem that those tools are similar because, well, they both have flow in the name and so on. But jokes aside, it's really hard to figure it out if you just play with a notebook and train your models, did some first courses on Coursera and try to figure out what to do next in order to bring it to the company you work in. Then it's confusing. And I think that showing this on this kind of diagram, which shows the whole MLOps process, can solve a lot of confusion that you might have. So if you look at Kubeflow, it goes for the obviously orchestration pipelines. Kubeflow pipelines are the main tool that is being used not only in Kubeflow, but also on the other MLOps tools as an extracted library. You have your orchestration pipelines, that's as well. In the training stage, you typically use both because you have MLFlow for logging all the parameters and Kubeflow to actually schedule and trigger the training. Model repository is a clearly MLFlow territory, like there's nothing in Kubeflow that is doing that. And also monitoring the models in production and taking logs from the models, that's the MLFlow space of responsibilities. All the other parts of these pictures, like storage or compute, well, Kubeflow helps with that, because if you run Kubernetes on top of your compute, that's how you will get access to it. And all the other stages are completely different things, like dashboards or feature store. That dashboards will probably come from things like Apache Superset if you want to go open source. Feature stores will go with Feast. So it's not like the whole ecosystem is just these two projects. What's super important is that whenever you are building your end-to-end MLOps solution, you will also have databases, streaming components, and so on. And the nice part is that you can build all of this from open source software, but for sure this tool is not enough to have a full end-to-end setup.
I think at the heart of anyone listening to us now, there is one big question. How to choose between these two? How do I choose, or when do I choose Kubeflow and when do I choose MLFlow? I think we touched a bit upon that, but maybe it's worth reiterating. What are the situations when we go for Kubeflow, for example?
I would have to agree also with, and that's a little bit of Maciej's point previously on, actually can provide the mirror side of it, which is, yes, you can use MLFlow when you want to start learning some things and have some structure along the way. But Kubeflow, on the other hand, is when you do feel that you have some of this expertise and have some of the structure, and you actually have a use case and need to utilize some more resources and a more complex infrastructure like Kubernetes, because when you have, most of the times when people come to Kubernetes is when they actually need to manage different teams, and need to deploy bigger models and need to have some isolation so they can run some AI at scale and track their code, which usually requires tools also, as we mentioned previously, like more automation with pipelines, etc. This is where they usually would then need to come to Kubeflow. But again, I don't want to say it's for more experienced users, but it's when you actually need to have teams of engineers working on top of bigger models that would require more scheduling and principles to actually be able to do AI.
What about MLFlow? We know it's ideal when you get started for seeing your experiments. What else, Maciej?
So it's also ideal when you use different tools. I mean, if you, for example, work on SageMaker because you like its integration with Greengrass and you have an IoT project, but you also really need an LLM with new Google's Palm 2 or BART or things like that, and you need both in your projects, you are running different types of models. MLFlow can be a tool that bridges the gap between those environments, right? So that's another place. And last but not least, if you need to package a code, not only for model training, but also the environment, what are the Conda or Python packages that you are using, what are the artifacts that are there, and you need a format that will be used across the company doing models in all various areas like multimodal stuff, voice, video, text, number data. That's also where you would go with MLFlow for sure.
And the main question almost comes, I mean, no, I have actually initially a controversial question. Do you think that long-term these two tools are going to be competitors?
Maybe, who knows? I mean, if you look at the roadmap of both Kubeflow and MLFlow, they are adding features that are missing in both of those tools. MLFlow is looking to add a pipeline-like functionality. Kubeflow is trying to put more tools on board. I think that in the end, realistically, the communities will be looking to somehow connect this together and maybe merge it into one setup, because that would be the most beneficial anyways. It doesn't make sense to duplicate work.
Does it mean that in Canonical we are a step ahead since we already integrated the tools? And to maybe give context to everyone here, on one hand, Kimonas already mentioned about charmed Kubeflow, but we also have our own charmed MLFlow, which is available for now also in beta. We are looking for feedback for the community. But at the same time, we integrated these two tools, and it seems that there is some love between them, and they work fine together. What made us, or Maciej, what was the actual need for us to get there? Because it was more of a customer need, actually. And where do you think it's going to go next?
Well, that's fairly straightforward. I mean, we are working for supporting open source software in a lot of Fortune 500 companies. They are making real production grade end-to-end MLOps, and everyone that started using Kubeflow immediately said like, hey, where is my model repository? So that's how it all started. I mean, that's why we integrated MLFlow to the picture and provided it there. Now, obviously, with time, they see much more benefits and using it in various different ways, but it all started from where is my model repo, basically.
I think also I know that in the Kubeflow community, there were also discussions on how to integrate these two tools, or maybe I remember it wrongly, but also from an engineering perspective, I think there were a lot of lessons that we applied, as well as needs that we quickly identified that the other tool could cover. And since we talked a lot, first of all, is there any other thing that you would like to add about the integration and how it works? It has a quite straightforward guide, if you ask me, but okay. I'll move actually to, we've been talking a lot about Charmed Kubeflow, about Charmed MLFlow, about open source MLOps in general, and I think the beauty of it, as I already mentioned, is that anyone can use it. If you want to deploy Charmed MLFlow or Charmed Kubeflow, you can just go ahead on our website, on our docs, follow our guide, and you get it quite straightforward. If you're an adventurer, you can even try integrating them, because we do have a guide for that as well. And then for Kubeflow itself, because we know it's a bit heavy, we also have an AWS appliance. However, if you're looking for a more enterprise solution, or you're actually considering having AI in production using open source tooling, we do have a commercial offering that includes support as well as managed services. And Maciej here, I think he's being very modest, because except for talking to customers, doing customer deployments, understanding actually what companies struggle with, his team is offering consultancy services to help companies ramp up and get started in their AI journey or move forward, depending on where they are. There are 4 lanes, from really exploration or exploratory workshops all the way down to POCs that Maciej's team can build for you. And I will not bore everyone with the sales part, but rather I would go back to some conclusions, because we are getting close to an end. What are your thoughts about Kubeflow and MLFlow before we wrap it up? Kimonas, you've been quiet for a while, and that's unusual for you, I'll have to say.
Maciej has really covered it so nicely that I feel like indeed it's those two tools right now, while they're going, it seems like each one tries to fill the missing gap. I think it's more important at this point for us to realize that the missing gap that each one have could be filled by the other group, so by the other project. So for me, it's really amazing, and I'm actually one of the people that helped from the Kubeflow side on a little bit on the MLFlow integrations, on getting it more up to the Kubeflow part. I think people should really actually see this question more on like, how can I actually get these two projects together? Because right now there is missing functionality between the two that can be filled. That's going to be more beneficial if you actually combine the two projects, so that you get the best value out of both, rather than trying to get a dedicated value out of just one of them.
I actually came up with a question, and I'm not sure which one of you would like to take it, but would you like to give a clear use case from the real world where these two tools worked well together? Maybe from a specific industry or something along those lines? Maciej, maybe.
Well, I think a very nice use case you can watch on the latest KubeCon transmissions that we did together with Andrea, and basically we're showing there how Kubeflow and MLFlow is used to work on patients' data to make a personalized drug discovery and cure a lot of hard to cure diseases. So basically those tools together, thanks to the fact that they were nicely integrated and also work with confidential computing well, allowed the pharmaceutical companies to basically make new cures for new types of diseases. And I think that this type of use cases are super important for everyone.
Thank you, Maciej.
I would actually like to ask this question on the reverse side, because I think, at least in my mind, there's this functionality of doing the model tracking and the versions and having the lineage is so fundamental that it's not just for one specific industry. But I'm actually trying to think if there is some case where you would actually not want to have it. And to be honest, I think I can't. But can you, Maciej, find like an example that, oh no, this is where I would not need to actually have this extra functionality?
Well, sometimes when we are doing hackathons internally and try to test out new ideas, some of them are so bad that I would avoid them being tracked. So that's one. But realistically, it makes sense to track every experiment, because you never know when you want to get back to it. Even if you now think that, yeah, this is a stupid idea, no one will use it, in 3 years from now, it might be a start of a new business that you will create. So
ambitious.
Always.
Except for open source, I think that's also in our DNA to be ambitious, or I would rather say it, innovative. And I think this has been it. We are getting close to an end, and I think we've covered a lot about Kubeflow, MLFlow. What are these two tools? What are the main differences between them? But not differences as in features, but rather where it's more suitable to use one or the other. We've been dreaming a bit, and we've on where the tools are going to go, but also we understood the differences, or sorry, not differences, but the importance of integrating them and working with them as a solution rather than two separate tools that they should never meet and they're just enemies. So I would rather say that the Kubeflow versus MLFlow should be turned into Kubeflow and MLFlow, and where to use them. Since we also have Kimonas here, it's worth mentioning that these two tools, and in general, any open source project gets better with people contributing to it. So don't be shy. Join a community, join Kubeflow community or MLFlow community, and try to make it better. And this has been it on my side. Thank you, Maciej, for joining us. Thank you, Kimonas, for joining us. And for all the knowledge that you've been sharing.
Thank you. Have a nice day, everyone.